Okay, this is just a quick tour of the adder drill that we have instrumented. So we use the power pack, and this orange box contains our EDAX data logger, 11 channels. We can go up to 12 channels. This setup, it is totally expandable, but we are going to use 11 channels. That is a battery just for backup power to the data logger. The data logger runs from this step down transformer, takes power from 525 volts down to 110 volts, and we have then just of course a DC converter to 12 volts to power the power supply. So it will run up from the power of the power pack. Our first sensor here, you can see here at the back, is a microphone. If you go here, so this is a random incidence microphone, and the idea is that the operator uses his ears, the auditory feedback from the drill, from the power pack, and of course visually from the dial gauges to adjust the operating parameters of the drill. So this is why we're going to measure sound that's emitted. We have a bunch of cables, so with metal sprag just to contain and protect the cables, both the power cable from the power box of the power pack, and these, they are the same length as the hydraulic pipes. Here the rotation unit, we have here a pressure sensor and another pressure sensor over here on the feed of the drill. So with that we can then measure the weight on bit, so the force that the drill is being pushed into the rock. Over here is a tilt sensor, you can see in yellow sticking out, that's going to measure the orientation angle of the drill. Another pressure sensor over here to give us an indication of the clamping force on the drill rod. Over here is a triaxial accelerometer to measure vibration response of the drill. So this will be probably one of our very important signatures to capture. Over here there are a bunch of strain gauge rosettes like this around the circumference of this flange, connecting the hydraulic motor of the rotation unit to this casing, and with this then we get a signal that is directly proportional to the amount of torque that's exerted on the drill. Then here at the bottom, that is a tacho sensor, and we will use these 4 slots to give us a signal. We will get 4 pulses per revolution of the rotation unit. So we can use that to monitor the rotation speed, and also possibly do advanced signal processing, as it will allow us to look at the data in the angle domain. This over here is our displacement sensor. Initially we wanted to go with a draw wire sensor, but we opted to go for this sensor. It's a laser displacement sensor that will measure we'll use that to measure the rate of penetration of the drill. Yeah, that's all the sensors, I think. This box is just houses the connectors for the accelerometer. There are 3 BNC connectors out, and they are too big to put into one of these sprags, so they are contained in here. So these strain gauges, we will put a cover around them just to protect them as well.